All right, today we're going to pull back the curtain on one of the most powerful tools a modern manager has: simulation modeling. Now, this isn't just some abstract theory. This is a hands-on way to create a quantitative forecast. Think of it as a virtual crystal ball for business that lets you predict outcomes, test strategies, and make much smarter decisions, all without risking a single dollar. So let's start by putting you in the driver's seat. Imagine you are in charge of the single hottest product on campus. Your challenge sounds simple, but it's incredibly tough. How do you keep it in stock for everyone who wants it without ending up with a warehouse full of unsold goods that are draining your bank account? This is the core problem that keeps supply chain managers up at night.
Okay, let's make this real. Your new job, you're the manager of the campus bookstore. There's this one textbook for a massive first-year course, and it is just flying off the shelves. Your mission is to model the inventory for this book over the next 10 days to figure out if your current ordering strategy is working or if you're actually heading straight for a cliff.
Now, every good model starts with some clear assumptions. For our little bookstore problem, the starting numbers are pretty straightforward. We know we're beginning with 1,000 books in stock. We also know we have a steady supply of 100 new books showing up from the publisher every single day. And looking at our past data, we're consistently selling about 80 books a day. That's it. These three numbers are all we need to start building our forecast. So, how do we actually build this thing? We're going to start with a tool I'm sure you all know: Microsoft Excel. Yeah, that's right. We're going to build a simple day-by-day simulation to see what happens to our inventory. This is really the first step in turning simple data into powerful foresight. The logic that drives our whole model is incredibly simple, as you can see right here. Each day, you start with your beginning inventory. You add the new supply that just came in. You subtract whatever you sold that day, and boom, that's your ending inventory. Of course, that number then becomes the beginning inventory for the very next day. It's a simple loop, but it's really powerful. And here's what it looks like when we run that logic for 10 straight days. You can see we start on day 0 with our 1,000 books. On day 1, we add 100, we subtract 80, and we end the day with 1,020. You just repeat that process, and by the time you get to the end of day 10, you can see our inventory has grown to 1,200 books. The model is already showing us a really clear trend. Seeing it as a chart makes that trend just pop, doesn't it? This bar chart shows a perfectly steady, straight-line increase in our inventory. Every day, we're adding a net of 20 books to our stock. Now, if you're the manager, this picture should immediately make you ask a question. Is this growth a good thing, or am I slowly walking into an overstock problem where all my cash is tied up in books sitting in a back room? So what we've just built here is more than a spreadsheet. It's a simple dynamic system. And to really get good at this, we need to learn the language of these systems. It really just comes down to 3 key ideas you see here: stocks, flows, and variables. First up, we have the stock. A stock is just an accumulation of something. The easiest way to think about it is like the amount of water in a bathtub. At any given moment, you can measure it. It's a snapshot in time. In business, stocks are everywhere: inventory on a shelf, money in a bank account, even the number of people working at a company. Now, that water in the bathtub doesn't change on its own, right? It's changed by flows. A flow is the rate of something moving into or out of a stock. Sticking with our bathtub, the faucet is the inflow, and the drain is the outflow. Flows are the actions. They're the verbs that make the whole system move. Okay, so let's apply this language directly back to our bookstore model. In our spreadsheet, the ending inventory column, that's our stock. The supply/day column is our inflow, and the sales/day is our outflow. The specific numbers we used, 100 for supply, 80 for sales, those are our variables. Those are the knobs we can turn to test different ideas. Once you see this pattern, you'll start seeing it everywhere in business. So why is learning this grammar so important? Because it gives us a framework to ask the single most powerful question in business strategy: what if? By playing with the variables, those knobs that control our flows, we can simulate all kinds of futures without any of the real-world risk. Let's try it right now. So on the left, you've got our original scenario, where selling 80 books a day led to that growing inventory. But what if sales were to perfectly match our supply? In the scenario on the right, which we're calling market equilibrium, we just change one variable. We bump sales up to 100 a day. And what's the result? A perfectly stable inventory. It doesn't grow, it doesn't shrink, it's perfectly balanced. And that brings us to this key concept: equilibrium. It's that state of balance you hit when your inflow rate, in our case, supply, is exactly the same as your outflow rate, our sales. The stock just holds steady. For a lot of businesses, hitting that sweet spot is the name of the game. But as we know, equilibrium can be a fragile thing. What happens when it's exam season and things get crazy? What if that popular textbook gets even more popular and suddenly your sales start outpacing your supply? Let's model that exact situation. So here are the new assumptions. Our supply is still stuck at 100 books per day. But now, a huge surge in demand has cranked our sales variable up to 120 books a day. We're now losing 20 books from our inventory every single day. What does the model predict is going to happen? And the visual result here is, well, it's pretty alarming. Instead of that rising line or the flat line, we now see a steady, relentless drop in our inventory. The trend is just as predictable as before, but this time it's heading towards a crisis. It's heading towards zero. And this right here is the true power of simulation. Our model doesn't just show us a scary trend, it gives us a hard number. It tells us that if this keeps up, we will run completely out of stock, a stockout, in exactly 50 days. We just turned a vague worry into a concrete deadline. That allows a manager to actually do something before they start losing sales and customers. Now, our model is useful, but it's also a bit static. I mean, in the real world, a manager who sees a 50-day stockout coming isn't just going to sit there, right? They're going to react. They'll change their ordering. And that reaction introduces a whole new level of complexity to our system, something we call a feedback loop. This is where a system starts to influence its own behavior. A feedback loop happens when the size of your stock, say your inventory level, starts to directly affect the rate of your inflows or outflows. So what if our bookstore manager sees the inventory dropping and decides to order more books each day? Well, the stock level is now influencing the inflow rate. That's a feedback loop, and it's what makes systems in the real world so dynamic and interesting. Now, these feedback loops tend to come in two main flavors. On the left, you have a balancing loop, which is all about seeking stability. Our manager ordering more books to fix a low inventory, that's a perfect example. It's like a thermostat for the supply chain. But on the right, you have reinforcing loops, and these are amplifiers. They can create a snowball effect, where a tiny change gets bigger and bigger as it moves through the system, often leading to chaos. Which brings us right back to the beginning. Why do we even do this? We build these models so we can see these complex connections, so we can test out our brilliant strategies in a safe environment, and to really understand the long-term consequences of the choices we make today. It's all about turning data and assumptions into a clear vision of the future. So I'll leave you with this one last thought. Our super simple model with just 3 little variables gave us a 50-day heads up about a major disaster. Now just imagine what a more sophisticated model, one that includes supplier delays, shipping problems, and those complex feedback loops, could tell you about the invisible risks hiding in a real, global, multi-billion-dollar company. That is the power you're now learning to wield.